breaking them down into their singular integers. Alright, so since we're dealing with alphabets, in this case right here, we only changed the first integer from AA to AB. AA had a value of 3104, as you can see on the top left corner there. And AB had a value of 3105. So the way you could mathematically show this increase of it through the interval is you can create this equation right here. N1 meaning the first integer or the first thing getting plugged in this case being A, and then you would add plus 1. You add 1 to that one, and it would give you your second number. In this case being N2. Alright? So that's how you could show this increase in one value. N1 plus 1 equals N2. That's first for the singularities, singular A. Because this is the first A in the sequence. If you change it, it's going to increase by 1 every time. Now, if you were to change the second A in the sequence, you'd get a completely different number. So this is our first equation just for the first letter in the sequence. A equals 97 as seen in the first video. So if you add 97 plus 1 equals 98. So using this formula, I can then plug in I can then plug in the value for B into where number 1 was and get the next chronological one. So it would be the value for C. It's obviously only going to increase by 1 because of this equation. Now, for this section, this is going to be our fundamental value, meaning any value in the beginning, we're going to compare it to 3104 because that's what's AA. That's the fundamental value, fundamental proof. AA equals that. So we're going to keep that 3104 in mind. Now we're going to create one new world. And instead of it being AB, we're going to do it opposite, BA. So the seed for the world is going to be BA. Alright? Then we're going to name this world BA so we don't get confused with other worlds. BA. Alright? I'll just leave it at that. It doesn't really matter. We're going to go ahead and create this world. Alrighty, so here's our newly generated world. We're going to go ahead and exit and save. Finalizing. Yep. Okay, cool. So, we go to BA and we check out the seed that it generated on the top left corner there. It says 3135. Alright? Keep that amount in mind. AA equaled 3104. AB equaled 3105. So that was an increment of only only 1, But now if we keep the first integer, which is a constant, and we change the next one, we can get a valid calculation. So BA in this case equaled 3135. Alright, and then we still have our AA over here. Still have our AA over here, which is 3104. So now we want to calculate the difference between those two. So we'll get the higher amount, BA. Put BA equals, well, BA minus, sorry about that, BA minus AA, and it's going to give us our increment by which it increased. So that being like that, we're going to do BA minus AA equals our interval. I for interval, okay? So we plug in the amount we got for BA, which was 31.35. Now we subtract 3104 from it because that's AA, that's the origin, the fundamental value. 3104. And then we obtain 31 as the answer. Alright? So that's the change in value between for getting to the second placement of the integer and increasing it by the next chronological figure that's going to come in the process. So now that we know that that increases by 31, we have our second dual alphabetical integer values. There's something that I'm calling it. Now that we have that, we can test it out, you know? Alright, now let's say I'm gonna plug in CA into the system. So the way I forgot. Sorry about that. Now that we know that it's an increment of 31, we're gonna go ahead and erase all this. That's our increment. So now we could make a second equation. The first one was really simple. N1 plus 1 equals N2. But now for this one, since we have two variables, we're gonna put N1 because that's AA. No. This is always gonna be the fundamental value. It's gonna be any multiple of A's put together right after another. So AA in this case and N1. The difference was a plus 31. So we're gonna make our equation plus 31 equals N2 N1. Okay, I'm keeping the N1 on the second part because like we did in our calculation, we kept the A indifferent. We kept the A the first integer indifferent. We didn't change it or anything. We kept that as an A. It was from an AA to a BA, so we had to keep that constant in the calculation. So in order to test this, we're gonna go ahead and try to get the next figure in the next figure in the equation. Now we plug it in. The value of AA, the value of BA. If we plug in the value of BA into where N1 is, that would be 31.35 plus 31 should give us our CA, okay? CA because the constant on the second side. So now we do the math. 3,135 plus 31 equals 3,166. Alright? So now we're gonna make a world called CA with the seed CA, just like that. Call this world CA, and using our equation, I calculated that CA seed is going to equal 3166. So now here's CA. Create new world. Alrighty, here's our new world. Exit and save real quick. It's finalizing. Alright, play. So my calculation was that this CA world was going to give us a seed of 3,166. Now let's see if I'm correct. Right there, top left corner, 3,166. Manually calculated through that equation that I just showed you guys. I know this video is a little long, so I'm going to cut it at that part. And yeah, I'll soon post up another one calculating triple integers with 3 letters. And I'll give an example. And yeah. Till next time on Mind Math. Well, yeah.